Hello, everyone. Thanks for joining me. It's a pleasure to be here. I'm intentionally following Bharath because in his journey implementing the Gravitino Iceberg REST catalog, he articulated back to us some additional features that he'd like to see in the future. And those additional features align well with Iceberg's overall forward-looking roadmap. And because these are really exciting, interesting features, I thought it would be worthwhile to just share with all of you some of the things that are coming in the Iceberg ecosystem that are going to make big differences in the way you look at data, read data, analyze data, and get performance out of data. And so from whatever Iceberg ecosystem you choose, Gravitino or otherwise, these may be things that are going to make a big impact on you or that you're going to want to search for. And because a lot of them are in their final stages, it's a great time to get involved in contributing technology. And so I've intentionally included in this presentation the Iceberg PR numbers and mailing lists where you can get involved in the definition of the final stages of this technology for yourself. The three areas that I want to focus on today are IRC federation, materialized views, and fine-grained access control. Catalog to catalog federation is the first point. And I don't know how many people know what federation means. I think that's kind of a weird word in this context. Hi.
Yeah. You know, means like, do I need to tell you?
No.
So I was saying, I know that.
Very good. I'm glad that you know. For anybody who doesn't know, it's a glorified way of saying that catalogs connect to one another. Let's suppose that you have more than one Iceberg REST catalog. Let's suppose you have one in a department and another in another department, and you want them to connect. And that's what Iceberg to Iceberg catalog federation means. Now, there are some very interesting ways to do this. We'll talk about one way, which is that one catalog connects to another through a service account, which gives super user privileges on the remote catalog, but doesn't provide fine-grained access control or privileges for what's on the remote catalog. And so what we want to do is do this thoughtfully in order to make sure that the remote catalog is still providing privilege enhancement for the privileges that you've put into the remote catalog. Materialized views are an old database concept. And a lot of people, Peter in the front is shaking his head. He's definitely used materialized views. A lot of you probably have as well. The purpose of a materialized view is performance. I have a table over here and a table over there, and I'm going to do a join. It takes a really long time to do that join. I'd rather not recompute that join over and over and over again. So I'm going to materialize it into a table, basically. But when I materialize it into a table, I'm going to write it on disk, and the next time somebody wants that join, it's done. I don't have to do it again. And so what the Iceberg community has done is to formalize this concept into Iceberg materialized views. Now, if you're a Snowflake fan, we're here at Snowflake today through their courtesy, that's great. They have a concept called dynamic tables, strikingly similar. And if you're a Dremio user, you have something called a reflection, which again is strikingly similar. Databricks has their own concept for a materialized view. And so what's the problem? We've got materialized views everywhere. The issue is that all of these technologies suit the engine that the specific vendor is providing, and they don't provide a general solution across engines. And so what the Iceberg community is attempting to do is to provide a solution that can be used with any query engine, a materialized view that can be used with any query engine. Well, that would be cool. And that's what we're going to talk about briefly tonight. Now, the third one is fine-grained access control. And what that basically means is the ability to filter rows and columns according to an individual user identity. I, as a user, may only be qualified to see rows where the user comes from the United States or lives in the state of California, or I may not be able to see PII columns, and so those get masked out. And this is very similar to the materialized view situation because who doesn't have this? I mean, if I go to Trino, they have a mechanism for fine-grained access control, and so does Spark, and so does Dremio, and so does Snowflake, and so does everybody else. Now, the issue is that if I happen to be using more than one engine, what do I do? And there's only one thing that you can do, which is to put your fine-grained access control into Trino, and then into Spark, and then into the other engine, and then because they don't cross and they don't talk. And so the idea of the Iceberg community is, again, let's tackle this problem in an interoperable way once and for all. Now, hopefully you can think of use cases in your organization why this might be useful. We certainly have, and we think that this is a fantastic way to achieve a community-oriented solution that builds up the community, because these are going to be community-oriented fixes. So let's talk about Iceberg peer-to-peer federation. In Gravitino 1.3, we're delivering this for the first time, and it's the ability to take one Iceberg catalog and connect it to another, but to do so in a way that you would probably want it to be done if they were your catalogs. If we're a catalog and we're going to connect to that catalog, we want to do it by passing Hoerth talked about tokens a second ago. We're going to take the token of the user who submits a query here, and we're going to pass that token over to the remote catalog so that the remote catalog knows the identity of the user, and the remote catalog can verify all the permissions and privileges that you've put into the remote catalog in the very beginning of the configuration of that catalog, so that the proxy effect of submitting a query there that's forwarded over here is in full effect. We don't want to have a service account connecting from here to here where I don't have any idea in the remote catalog who the actual user is. That totally defeats the purpose of our AI agent creation and our security configuration in general, because unless we know who the user is, we can't determine if they're really appropriate to view the data or not. And so what I've got here is a picture where we have a user in a compute engine. The token gets sent to the local catalog. It gets forwarded to the remote catalog where all the serious work gets done, and the whole thing goes back. So this guy is a proxy. Now, I had someone earlier today say, well, that's great. I want to put this guy at the hub of a hub and spoke architecture in which I've got other IRC catalogs in various departments and places and geographies all over my organization. And the answer was, good idea. Because what this allows you to do is to submit a query here and then to have it forwarded automatically to wherever the owning catalog actually resides. Hopefully you think that's pretty cool. I certainly do. If you don't have what's called user impersonation, to forward the user identity, this is what we would call it if we were Oracle users, user impersonation. We're going to forward the user identity over there. If we don't have that, we have a whole bunch of problems that basically boil down to the fact that we don't really have an audit log. We don't really have any of our governance captured, and we don't have any means to understand if it was an AI agent who actually did this. All we have is a service account entity, which doesn't tell us anything about who the identity responsible was. In a true IRC to IRC federation, you have three distinguishing facts. Number one, you have transparent proxying. Remember I said that if you have that catalog there, it's going to proxy a request over to me. I don't want you to do anything other than to give the query to me. I'm the remote catalog that has the user's actual privileges in the data that they want. You proxy that to me, I will give the answer to you, you hand it off to the user. And that's the only role I want you to fulfill. Hoerth talked very effectively about JWT tokens and JWT pass-through. And so you already know that JWTs, which are the token that you get from the OAuth provider, is a great way to authenticate who the user is with a very minimal registration process. The registration of a remote catalog to the authoring catalog needs to be efficient. I mean, we don't have all day to stand around here registering catalogs. Many benefits, because imagine in a hub and spoke architecture where I've got a catalog that federates out to all these other catalogs. If I'm an agent provider, Peter here, who's going to speak next, is an agent provider. One of the things that Peter's going to get is an unbelievable surface area of data available to the agent, because all of the catalogs in my organization can be federated together. From a single point, I can see all the organization's data. So imagine the surface area that he has available in order to make agentic. It's fantastic. Okay, let's shift gears and talk a little bit about Iceberg materialized views. I mentioned a second ago that a materialized view is meant to improve performance. Let's suppose I have 10 million rows in a table, and I'm going to join it with another table that has 50 million rows. These are typical Iceberg data sets, but to join them may be a complicated join with some filter conditions and whatnot. And so joining these two is going to take a long time, forever. This person forever. That's very well said. It's going to take forever. And so I want to compute it once. I can't be computing this over and over. And once I compute it once, I want to save it. That's what a materialized view is. Now, the Iceberg community has had no support in the past for materialized views. If we were an Oracle user, we would know materialized views are a common thing. And as I mentioned before, all of the Iceberg vendors support materialized views. Here at Snowflake, it would be a dynamic table, or it would be a reflection if we were at Dremio or something like that. So that's all great if we're willing to conform all of our queries to that one engine. But in a situation where we want to have a whole bunch of different engines using the same set of materialized views, we're stuck. And so the Iceberg community has developed this notion that I have a couple of big tables over here, and I'm going to create a couple new first-class objects. The first is what's called a common view. Now, you know what a view is. A view is just a SQL expression. A common view is a SQL expression that's been enhanced in only one way, and that way is to point to a storage table. And this storage table is the materialization of my join, or whatever it was that I did in this view that I wanted to materialize. So what I've got here is essentially an Iceberg table that's being pointed to by a view. And these two form a relationship where we define a freshness value. Extremely important, because the freshness value is going to help us determine whether or not we really want to use that materialized view. Now, in Iceberg, when you do a write, you create something called a snapshot. And every time you do a write, you create a snapshot. And so it's very easy to tell that if I created my materialized view yesterday or 3 snapshots ago, and now there have been some updates, do I want to use that materialized view again? Well, perhaps, but perhaps not. I mean, it's not fresh. It doesn't have all the updates that I want. And so we have to determine and give a rating to whether or not the materialized view is something that we want, right? If there have been other writes, well, maybe, maybe not. And that's why we have this freshness ranking with some actual nuances in terms of what are we going to do, right? So fresh is the first thing that a catalog will determine at whether or not your materialized view is fresh. It'll say, oh, it's fresh. Now, fresh means it's caught up with the latest write. There's no write that's not included in the materialization. So if I've got a big table here and a big table here, and I have joined them, and I've got a materialization over here, I've got essentially a copy of those two in a join that I've done over here. Now, if I do a write over there, this ain't fresh anymore. So if the catalog says this is fresh, you're good to go. You've got the latest data. Okay, so fresh is obviously good. Stale means somebody's done a write into one of those data sets, and you have a decision to make. Do you care that the materialization does not have your latest write in it? Well, maybe. Maybe not. Depends on what the write is and what the data was that you're using, right? And so right now you have a decision to make, and the Iceberg standard recognizes that you may sometimes want to use this or you may not. Then we have over here invalid, which means that the schema is changed on one of those tables that makes up your materialization, or something else has happened such that the number of columns has changed, or some other definition. So what we have here now is a materialization that's not any good anymore, can't be reproduced anymore. And unfortunately, they don't specify the remediation here. They don't say, hey, Mr. Catalog, you've got to fix this. You need to drop that materialization. They don't go that far. What they tell you is your materialization is invalid. Take the appropriate action. And the appropriate action is probably to drop it and recreate it. But that's either for the catalog to figure out, And you can choose the catalog that does the best job of figuring that out, or you do it manually. Okay, so what have we got here with a materialized view? Catalogs can have the opportunity to do a few things for you. They can create the object linkage. Remember I said the only thing between a common view and a storage table that makes either one of them different in any way is the fact that there's a linkage from the common view to the storage table. That's cool because in an Iceberg ecosystem now, these are first-class entities. You can still query the common view. You can still query the storage table, but only when you ask about the pair will you get a freshness computation. And the freshness computation is what tells you, okay, I can see that you have a SQL expression for this materialized view. I will look at the snapshot values for the latest right here and the latest right here, and I will tell you whether or not this materialization is still fresh. If it is, you're good to go. If it's not, you decide. Now, over here, we have a refresh lifecycle. Now, if you do writes to any of these tables on a regular basis and you've got a materialization over here, how do I keep this thing fresh? Am I going to have to do a lot of work every time there's a write over there or a write over there in order to materialize this? Well, that's up to your catalog, and it's up to the catalog that you choose. Some catalogs will be aggressive and they'll say, you know what, I've got this. I'm on it. I know exactly what you want. Or you will set up a policy. I, as the catalog, am going to look at those two tables, and every time you do a write on one of them, I'm going to refresh this materialization. Ooh, thank you, catalog. That's a nice service. Or I'm going to refresh these on some kind of time basis. You know, you're making a bunch of writes over there and you're making, I can't be refreshing all that all the time. It's too much work. So what I'm going to do is I'm going to look every hour. You tell me how often this needs to be. Every hour, half hour, 2 hours, whatever. You tell me. And I'll go look over there. If there's some writes, then I'll make a new materialization over here. So see, there's a lot of ways you can program your catalog or configure it to determine how fresh do you want me to keep these? How hard do you want me to work? And then the catalog can take the appropriate action. Now over here, we've got this freshness tolerance idea, which is to say that you already know that it doesn't always matter if my data is fresh. And, you know, I missed a write. Geez, it's not, that's fine. You know, it's not a big deal. So what you may want to do is express a freshness tolerance to the catalog that says, yeah, you know what, as long as we're within 2 hours or something like that, or 4 hours, that's fine. You know, I've got most of my writes. I've got 98% of them. Then that will be something that the catalog uses to determine if you're fresh. Okay, let's talk about the third topic before I use all my time here. Fine-grained access control is a super exciting feature because everybody wants to perform row filtering and column masking. And this is another one of those features. It's like, well, what's the big deal? I'm already doing row filtering and column masking, and you probably are. But if you're doing it today, you're doing it because you're using engine number one, engine this, whatever it is, Trino, whatever it is. And then when you go over to this other thing, you have to program it again because all engines do this in a proprietary way all to their own. And so what we want to do, what the Iceberg community is attempting to do is to standardize the way this is done. We've got a compute engine over here. It's going to ask the catalog. The catalog is going to accept policies that you derive. And then in the Iceberg solution, it is going to provide the compute engine something called read restrictions. The big question in row and column access control stems from, okay, I need this table filtered. Who's going to do it? Right? I've got this table, it's got 50,000 rows or 50 million rows. I want to filter out all those rows where the state is California, and I want to mask this column for this certain identity. Who's going to do that? Well, there's a couple of choices. Choice one is the catalog does the work. You tell me what you want, I will give you a filtered table. That's it. Because I trust myself, I'm going to do the work. Eesh, that puts a big job on the catalog. That's a big job. And right now, catalogs do not have compute. Catalogs don't compute queries. They don't filter tables. They don't do any of that stuff. And so if you're asking me to get into the business of that as your catalog, I don't know. You know, it's a lot of work. So the other choice is the engine does the work. The engine does the work. Now, if the engine is going to do the work, Trino is going to do the work. Spark, whoever it is over there, he's going to do the work. Well, if he's going to do the work, I have to tell the engine what's the filter here. You were the one who told me. You told the catalog what the filter is. I only want rows from California, and I want the Social Security column. Okay, so now that information has to get down into Trino because the engine's going to do the work. And so I have to figure out a way to get that into Trino, and that introduces the idea of a trusted engine versus an untrusted engine. A trusted engine is one that has proven that they're up to the job. And even though this sounds like, wow, this is amazing stuff, this is exactly what the Iceberg community has done. This is exactly the structure they have created. And so you're going to see more and more about this. It's extremely exciting. And now you're going to know the vernacular, and you're going to see trusted engine. Oh, trusted engine is one that has proven that they can do this. Okay, that's really, really cool. And you're going to see untrusted engines are ones that are too small to obey the rules, can't verify this and that. I mean, in order to be a trusted engine, the Iceberg community went to Trino and they said, we're going to send you a bunch of read restrictions in a certain format. Are you sure you can implement them all? Yeah, we're sure. Okay. So here it comes. This is a typical read restriction. This is a very simple one. So I have asked for a table, and here it comes. I performed, as the engine, I performed a load table request. And here's what I got back. Wow, look at all this. I got some read restrictions. Here's a group of read restrictions that implement the fact that I want to put in a row filter where I only want the ones where some field ID number 2, column number 2, is equal to US. That's the equivalent of this, because these instructions that I'm going to pass are in a format called an Iceberg expression, which is another whole bag of technology, right? So if you are really interested in this topic, you can go read about Iceberg expressions, and that will be the mechanism under which these filters are expressed. Here's the next one. I only want these column projections, where field number 3, I want you to replace with null. So field number 3 is a Social Security number or something. I want you to null that out. Wow. That's really cool. And you can imagine that for the typical row and column access policy, it gets gnarly complicated. And so for really complicated ones, there's yet another way to do that called a UDF that the catalog passes to an engine, and the engine has to perform the operations in a UDF. So let's talk about what this really means in practice. We talked about engine trust. We're trusting you, engine. I do not want these Social Security numbers exposed. So we're trusting the engine to do that. Number 2, we are going to have to provide the identity back to the agent. Barath talked all about how we've sent around the OAuth token that represents the identity. We sent it to a variety. Where's it going now? It's going to the catalog. And the catalog is the one who's going to have to verify, wait a minute, who's not supposed to see column 2? Oh, here's a token. Oh, well, that's not this person. Oh, here's the person that is not supposed to see column 2. Okay, that's fine. So the instructions I'll give to Trino are this person with this JWT doesn't get to see the column. So all of a sudden now there's new uses for your identity within the catalog, and there will be different mechanisms such as UDFs and the Iceberg expressions that we looked at a minute ago in order to implement these restrictions. Quick summary here before I turn over the floor to another speaker. I've summarized here all of the things that your catalog is now doing for you. Ooh, your catalog is working hard. It already implements table access and credential vending, and now I'm certain before the year is over, there will be catalogs who implement row and column masking, row filtering. And so you're going to have a whole bunch of new choices and a whole bunch of opportunities to do this in a completely new vendor agnostic way. if you're interested in any of this technology and want to know more, I've provided on this page additional resources. And that includes, you may have noticed that in this pitch, I provided the PR numbers here. This is an Iceberg PR number in the Iceberg community. So you go here and here's where the GitHub is, and you can find out all the brutal facts about how materialized views or row and column access is being planned, when it's being voted on, how you can participate, and I'm sure that they would love to have any feedback that you have. Any questions before I go? Yes, sir.
So thanks for really the whatever you highlighted, it's a real problem with that.
Good.
And thank you very much for addressing that. The materialized view, the query rewrite, how is it? I think when the engine will come and run the query, how will it will know that whether it is going to use materialized view or is it now the table underneath?
Sir, that's a fantastic question. If you don't mind, I'll step back one notch for people who may not be familiar. This gentleman asked about query rewrite. How will query rewrite be performed? And I want to explain what that is for anybody who doesn't know, because I didn't talk about query rewrite just then. The idea is that I have a materialized view that I made yesterday or half an hour ago or whatever it was, and I want my engine to automatically use my materialized view rather than to recompute that join. Remember, I said I've got two tables that I have materialized into a join. And so, Trino, I don't care what I tell you in the future. If I say join A and B, don't do it. I want you to use my materialization instead. That's query rewriting. And the spec doesn't say anything about query rewriting because that's the engine's job. That's the engine's purview. And this is Iceberg, where, you know, table formats and catalogs and stuff like that. And so if you have a smart engine, and if that smart engine chooses to rewrite queries, that's where that action will take place. Now, the reason why this isn't a big deal, in my opinion right now, is because the vast majority of materialized views are used in dashboards and things like that, where you don't need to have the engine automatically replace. You know what your queries are, and so you just the materialization I mentioned before is a first-class object, and that means you select star materialized view. There you go. Query rewriting achieved, but it was done through your intelligence rather than, and because the materialization will be a first-class object, if you're interested in agentic action, the agent will see the materialization and it will know. So that's a large part of why query rewriting is kind of a thing to come later in most cases.
Thank you.
Yeah. Other questions? Yes, sir.
So, you mentioned about trusted and untrusted engine, right?
Yes.
So is this specific to every query or a size of a cluster? Because it can happen that Trino cluster is small and it's not able to handle some of the computation. So then it will return it's untrusted, or how does it work exactly?
That's a very, to tell you the truth, that's a very good question that I've actually, I haven't thought of. And so let me answer this way. The way I've read about it and the way I've understood it up until now is that the trustworthiness of the engine is determined by the identity of that engine and their general behavior. So Trino has evaluated this process and they've said, we will implement all that and we will prove we do it right. And so in general, they want to be a trusted engine. Now, there are going to be other engines that are very small or that are using, are you familiar with the scan plan interface on a Iceberg REST catalog? Scan plan is an interface where you submit a plan and you get raw Parquet files back. So you have to do a lot of work. And it could be that your PyIceberg script is not a trusted engine or some really low-end engine or a variety of things that you've stuck on the end there. And so they're untrusted. I mean, they're just little computational things that don't have the full weight of a Trino or a Spark. Now, is there a situation where an engine would say, well, I'm trusted for that, but this other stuff over here is more complicated. I'm not trusted for that. And, you know, I don't see that as inconceivable. This is new territory. And Trino is the only one that I've so far heard say, we will do it. Now, I have seen the Spark community has released an implementation, sorry, the Iceberg community has released an implementation for Spark. And so there's going to be a Spark implementation as well. And the two most important engines, at least in my world, are Trino and Spark. So, the two big ones are covered, but we'll see what happens with the rest of them as time goes on.
I had one more question about materialization.
Yeah, sure.
So whose job is it to think about optimized materializing of the table? So I'll give you an example. So suppose I just add another column and I refresh the materialized view. So I should not recreate an entire table, right? So ideally, it would be good if we are able to only compute the column and then somehow use that.
So all matters of intelligence related to the selection of materialized views, what should be materialized and what needs to be recreated when you add a column or something like that is going to separate the great catalog implementations from the not so great. Now, what I mean by that is that I mentioned before that if I have two tables over here and I add a column to that one, my materialization here will have an invalid state on it. Or if I delete a column over there, my materialization will have an invalid state on it because I can no longer reproduce. You've taken some columns away, and so I can't build this anymore. And so unless you redefine what you want me to materialize, I'm worried that I'm not going to have the right stuff in it. So that is an operation left for the reader, right? The great catalogs will say, I know what you mean. I'll fix it up for you. And in fact, I'm aware that there are platforms today who will even go out of their way to watch your query behavior and to recommend to you the materializations that you want to have. If I watch all your query behavior, it's like, you know what, you're joining these two tables over and over. It's crazy. So I will just create a materialization for you, but no catalog is obligated to do that. It's just something that you'll have to look for and say, hey, Mr. Catalog, do you do this for me? Kind of in the spirit of the stuff like, do you automatically refresh my reflection or my materialization? Do you automate this and that? Yeah. Otherwise, it's you.
Yeah. Thank you.